Welcome to the MatterHackers podcast. I'm Dave, VP of Products and Technology here at MatterHackers. I'm excited to bring you along this journey. I'm having a conversation with Emma from BASF and talking about the BASF product portfolio and how a huge chemistry company is contributing to the technology and the growth of both desktop and industrial 3D printing.
Welcome to the podcast.
Thanks.
This is our first in-person podcast.
Oh, nice. I'm glad I could be the first in person.
Thanks for being here in SoCal with us.
Of course.
So, you are Emma from BASF. What's your background? How did you get into 3D printing and employed at BASF?
Yeah, so I started at BASF about 6 years ago now, and I was not in 3D printing when I started. I was working in UV curable coatings and dispersions. And different UV curable resins, and worked in that on the product development, R&D side as well. And then we had a 3D printing R&D group that worked in, a lot of those same UV curable materials, working with DLP printers. There was an opening there, and I was like, that sounds like my background would work perfectly. And sounded like a really cool group to be a part of, and so started working there in the R&D team. And as of almost a year ago now, I've been in my current role, which is the technical specialist for our filament product lines. So now customer-facing role, different 3D printing technology, but still 3D printing.
Nice, yeah. So we've gotten to know each other over the last year, and last time I was in Detroit, we got a tour around your lab.
Yes.
Which was really cool. All sorts of cool, crazy new technologies and materials testing and stuff like that.
Yeah, thanks. Yeah, I've got lots of different printers for all our different product lines. So yeah, a lot of different applications.
Some big, huge, some small, and everything in between.
Yeah, we try to represent the whole range of what's out there.
So obviously you have a technical background. Is it like more engineering or materials or?
Yeah, so I was a chemistry major.
Okay.
So yeah, more materials. Love chemistry.
Awesome.
Yeah.
I'm a mechanical engineer, so I hate chemistry. So in some ways we have to be arch enemies, and that's okay.
Yeah, and I'm like, no, not mechanical engineering.
Yeah. Somehow I signed up for it. I got tricked into it. Okay, so BASF. Who is BASF as a company? I know, at least myself, I'm familiar with the word BASF. I know I've run into it a bunch of times, but from your perspective, who's BASF as a company? And then next we'll get into the 3D printing specific stuff. But
Sure. So BASF, the really easy answer is they are a huge chemical company. We supply raw materials for probably so many of the products that people use and don't even realize it's BASF products, but because we are generally a raw material supplier, that's what BASF does.
I've done some peeling back into raw materials in everyday life, and I was like, I'm always surprised how often it's like, oh, that's a BASF nylon or something like that as the root material. You'd never know it, but it's all over the place.
For sure.
Especially automotive and a bunch of applications like that.
Yeah, definitely. Automotive coatings are a huge part of BASF. But yeah, there's definitely a lot of everyday products as well. Care chemicals and a lot of household items too. So you're closer than you think.
Yeah. Whether you see the logo on those final products or not.
Exactly.
So BASF, when it comes to 3D printing, how is BASF involved in 3D printing in general?
Yeah, so BASF Forward AM is the official 3D printing group within BASF. And so that is a group that I'm a part of. And so we still are a material supplier, this time for 3D printing materials. And so we have 3 different product lines, filaments, powder bed fusion, and resins, so for SLA or DLP printers. Yeah, so we have all different product lines. We are machine agnostic, so we work generally with open systems, but not exclusively, but our goal is to have our materials certified on as many printers as possible. We want to have our materials accessible but also still offer a full solution for our end customers.
That was the impressive part about walking through your lab, is how many printers you guys had. And I know some of them, as much you're machine agnostic, but you also want to be participating and aiding in pushing the technology forward on all platforms. It looked like, from what I saw in the lab anyhow.
For sure. Yeah, like I said, we try to have a full range of, smaller, cheaper printers that, anyone could have in their home to, higher end industrial printers and everywhere in between. And really all of the machines that we have in our lab, we believe in, and we want to push and help and support the machine manufacturers as much as we want them to give us feedback and help with our material development as well.
Yeah, and that partnership seems to be very fruitful from what I've seen of all the printed stuff that was in the lab and all the success you've been having on the powders themselves, on the photopolymers, and on the FFF or FDM materials.
Yeah, definitely. We also, like I say, pretty much any printer we do have, we also have a partnership with that machine manufacturer, that company. It's definitely a partnership. We support them, they give us feedback, we talk about potential applications, so definitely a true collaboration.
And a lot of back and forth.
Oh yeah, for sure.
In terms of resins, what's a cool photopolymer resin project or company or application you've seen come through the lab?
Yeah, so one of the newest things that's come through the lab and really exciting is that we have a ceramic resin. So it's still UV curable, and you don't need to do any post-processing. I still need to learn more and more about it, but when the first ceramic print went through the lab, we were all very excited.
Nice.
So it's a really cool material, very unique as well.
Yeah, the first ceramic 3D printed thing that I held, I was surprised how heavy it was.
Yeah.
Dense, very dense.
For sure.
Which is cool.
Yeah.
And then what about powder bed? So when I was in the lab, you guys had a couple powder bed fusion options. Any cool projects you've seen out of that or those machines?
Yeah, definitely. I think one of the coolest and also probably most relatable projects is working with one company, Zenith, and the NFL currently is sponsoring I don't know if it's a contest is exactly the right word, but basically they want to have safer helmets for the players. I mean, of course, concussions are a hot topic, and so we have a TPU powder, and so we've worked with Zenith on trying to really optimize the padding in helmets. Reduce the impact on your head and reduce concussion. So that's been pretty cool.
Big priority. I know that comes down, the reason I think that's cool is it comes down to not only the materials, but the design as well.
Yes.
Because any elastomer or urethane, you can really design to be rigid or flexible based on the structure of it. And the flexibility you have with powder bed fusion is remarkable because it's all self-supported.
Yes, for sure. And really with really all three of our product lines have either flexible or TPU products. And the coolest thing with 3D printing is, in traditional BASF, they really know Elastolan is the raw material in the product line for TPUs. And there's just hundreds and, so many different products, but with, different hardnesses, different properties, like slight adjustments. But with 3D printing, you can have one material that you can hit all different hardnesses and different designs, and so you can really utilize design to have one material cover a lot of that space, which is really cool.
Yeah, absolutely. I mean, I've seen that many times across all the product lines, but those conversations are just becoming more based, the customer conversations are becoming more based on technical data sheets than they ever have been. So creating those technical data sheets becomes way more of a priority in 3D printing than it ever has been.
Yeah, for sure. And that's something that, on the technical side, that's what, we're the ones that create those technical data sheets, and that's what we work on. And even right now, ours are evolving to get even better. And, but that's definitely something we know. I mean, if I was on the other side, one of my first things is okay, I need material properties. I'm a chemist, I need numbers, I need data. So we know that providing that really good data is only helpful to you or the end customer. Yeah,
you may or may not trust the sales guy, but he can either look like a goofball or a pro by the technical data sheet at the end of the day.
For sure, because it's like me or my counterparts in Europe that are literally doing that testing. And
that's the prove it moment.
Yeah, for sure.
But I love the evolution of more focus on the technical data sheets and the material properties. That means we're the customers in 3D printing are expanding to consume enough people that those conversations are the ones that will kickstart real relationships, cool case studies, and just rad applications at the end of the day.
Yeah, for sure. When you want the more industrial applications, especially, a lot of people, they know certain properties they need to hit, and if you can at least offer the baseline, yeah, it really helps get you started or give you a leg up as well.
So the third pillar of forward AM would be the FDM or FFF materials. Tell me, as if I didn't know the answer, the portfolio of materials that forward AM has in your FFF line.
Yeah, so our filament product portfolio is pretty huge. But kind of the best way that I like to look at it is like kind of material categories. So we have our standard filaments, so PLA, ABS, PET. You know, that's where you're going to have your, you know, commodity materials, lots of different color options, easier to print materials as well. But where we really like to focus is our higher end engineering grade materials. And more for industrial applications. So some of our engineering materials, for one example, is our PC ABS FR. So that FR is fire resistant. So it's a PC ABS fire resistant blend. And then we also have a really big focus on our reinforced materials. So we have 2 carbon fiber materials, PET carbon fiber and a nylon carbon fiber. Those are kind of like what I like to say if you know, you've worked with PLA, ABS, but you want higher mechanical properties, better mechanical properties, but not something super complicated or difficult to print. Those two are great. Especially PET carbon fiber.
Yeah,
anyone
can't
can
go
print
wrong
that.
with it.
Yeah, anyone can print that.
The stiffness you get out of it is just perfect.
For sure. We also have 3 glass fiber filled materials as well. So even higher end mechanical properties there. A polypropylene, PA6 and polycarbonate glass fiber.
A little bit of everything.
Yes, for sure. For sure.
That's awesome. And some of the metal materials that have been developed, I think, are, as I've been describing for the last 4 years, the coolest thing since sliced bread in 3D printing. I think some of those applications, and we'll get a little bit more deep into that in a second, but you've got to print something, you know, maybe it has a specific application, but maybe it doesn't have a specific application. What do you grab off the shelf?
For metal?
Nope, just for any material. You get to pick what you're going to print with today. What's your go-to?
Ooh, my go-to. Depending on what we need. If we need those higher mechanical properties, I'm probably going for the PAHT carbon fiber. If I want easy to print but more flexible, our TPU 64D. It's a harder but still flexible material. Prints amazing. It's relatively new, and yeah, I'm still kind of geeking out over it.
Nice.
So I'm like, wow, it doesn't give me any trouble ever, and prints really nicely. So those 2 are probably 2 of my favorites. Metal as well. We can get more into why I like metal.
Yeah, but, oh my goodness. Because it's the coolest thing since sliced bread.
Yeah, exactly.
I've always thought that the BASF Tough PLA was industry leading. It's always the easiest to print with.
Yes.
And it makes me feel like a fool to print with regular PLA ever again.
Yeah, that's a good point. Yeah, people see our PLA Pro 1 and they're like, wow. Everyone's just like, the surface looks amazing. Yeah,
there's some magic potion in that.
Yeah, and easy to print as well.
That's my go-to for off the shelf.
Nice.
The Pro 1.
That's a good one.
Cool. To dive into metal a little bit. So we've already done a podcast on metal. That was sort of interviewing some of the industry applications that we've seen, both in aerospace and in education. We have a few customers that really highlight some of the use cases there. But I wanted to dive into more of the deep versions of metal, how it came to be, and some of the applications that you've seen come through, both customer applications or maybe your own applications. How did metal filament come to be at BASF?
Yeah, so it is actually based on our Catamold technology. So very well known process within BASF based on metal injection molding. And so that's kind of both of our metals are based on Catamold.
And metal injection molding is not new. It's been around for a while.
Yes, very well processed.
All that art mixed with science is pretty well established. I mean, I think that's why the ultrafuse, both the 316L and the 17.4 pH, exist where they are, is because it stands on the pedestal of 30, 40 years of technological advancement in metal injection molding, where all the complicated post-processing stuff is really easy now.
Yeah, it's very well known. That's also one of the great things about being part of BASF is we can draw on that chemical know-how and really then make, our lives easier, but also make our products just that much better. So, yeah.
So what's the difference between right now the portfolio has 2 metals in it, correct?
Yes, Ultrafuse 316L and 17.4 pH, both stainless steel.
So if a customer came and was like, cool, I want to print in metal, which one do I pick? How do they come to the decision of which one of those to choose and why?
Yeah, so in general, 17.4 is going to have better mechanical properties in general, higher tensile strength, modulus. It's also much harder and very good, all-purpose, very widely used in the industry. So if you want the better mechanical properties, 17.4. 316L has better corrosion resistance. So if you want it in a food or also better chemical resistance, so like a food or salty, humid environment, anything like that, then I would go with 316L.
My only knowledge is 17.4 is a tool steel that's really hard and you can't bust it up, and then 316L is what I'd use on a boat.
Yeah, there you
Those are my simple examples.
Yeah, that's perfect.
Because that's a pretty harsh environment on a boat.
My other favorite fun fact about 17.4 is that it is magnetic. So for me, when I'm printing, a bunch of the same part in the lab, and I inevitably forget which one is which. I hold it up.
They look the same?
Yeah, they look exactly the same. So I hold it up to a magnet. I'm like, okay, this is 17.4. So yeah, I've found it very helpful.
All right.
Keeping track of things. But yeah, it's good to know.
I will remember that because we have many floating around parts in the office that who knows what they were printed in sometimes.
Yeah, exactly.
Cool. And is one of them easier to print with or harder to print with, or easier to debind and sinter or harder to debind and sinter?
No, they really process very, very similarly. Print parameters are almost identical, if not identical in a lot of cases. And no, they really are easy to print. You can print them on any benchtop printer. You don't need a high temp printer. You don't need any crazy printer specs or anything like that. A lot of times I'll print mine on Ultimaker, put them on arrays, so really, really accessible in that regard. And then for post-processing, same process as well. We work with our partners, DSH Technologies. They are the experts in the post-processing for debinding and sintering, but for both materials, you send them to DSH and they get processed in the same way. So.
Shout out to Brian.
Yes.
Brian's a legend.
Oh, yeah. He's the expert. When I say, I can help you with that half the time, it's like, I can have Brian help with that.
Yeah. He's a great backstop of, really understanding the technology. And DSH, the partner company that performs the debinding and sintering, is supposed to back up a little bit. Yeah. You print the parts in your lab, but then we send them out to the debinding and sintering partner in the United States. That's DSH.
Yes.
And then they debind, sinter, heat treat, and then send back to the customer.
Yep.
And that's the regular flow of those metal parts that you can print on your at-home FDM or FFF machine. And Brian works there, and he's awesome.
Yeah.
And a great backstop of technology, even when it comes to design for manufacturing, which I think is one of the biggest burdens of succeeding in printing with metal, which we've talked about at MatterHackers many times, is you are now designing, as an engineer, you are designing for a new manufacturing method.
Yeah.
Therefore, you must consider the part as a brown part in its weakest form and all those sorts of things of... it's easy. You can succeed a lot. There's also a pretty, I'll call it a shallow learning curve. It's easy to print simple parts.
Yes.
But it really gets a lot steeper when you try to print complicated parts. But sometimes I am very impressed with some of the things that I see have succeeded through the debinding and sintering stages. For
sure. No, I would totally agree with that. There definitely are more design constraints around the metal just because it has to go through this post-processing. Like you said, when it's a brown part, that's after debinding. So it's very fragile in that state. It's almost like a wet sand consistency, so you can imagine you can't just print anything and have it survive in this wet sand state. So you really have to design for that. So, knowing kind of in general the guidelines ahead of time really sets people up for success versus oh, let me just print the craziest, biggest thing I can think of and hope it works. It's like, let's start a little smaller, but then we continually see people push and push, and things that we think definitely won't survive often do, and we're kind of amazed. So, we definitely see people pushing the boundaries and testing more and more of what can be accomplished with the technology. So it's been really cool to see that.
Gravity and wet sand.
Exactly.
They're not buddies.
No. So printing like a really tall, skinny, post or something.
Yep.
That will just collapse in on itself.
Yep. If you got anything that looks like a pancake, I can guarantee success.
Yeah.
Anything that looks like a PVC pipe, 12 inches tall, standing on its end, will probably collapse. But there's a lot of in between where there's, like you've said, a lot of applications where we've seen succeed that are really great, but sometimes impress us even as we've seen a lot of things being processed through there.
Yeah, definitely.
If you have like 2 words of advice for succeeding at metal 3D printing, what would they be?
Ooh. Patience and perseverance, I guess I would say.
Yeah.
Nice. It's a new technology. A lot of people can, if one thing doesn't succeed, it's like, no, we can make this succeed. A few little tweaks, don't just give up on your part.
Yeah.
So,
it comes down to that design, the design for manufacturing, and it's not just designing for 3D printing, it's designing for 3D printing followed by wet sand.
Yeah. Yes. Yeah, you need a 3D printable part and then one that can survive that post-processing.
What applications or case studies or cool parts have you seen in the metal, BASF metal materials have you seen?
Yeah, I mean, we see all sorts of different things. A lot of, really what we see most often is a lot of like jigs and fixtures is really where, metal can come into play. Anything where you either need to customize a part or maybe you need like, 100 of a part and not thousands. That's really where we can see metal 3D printing. That's really where its value is.
Well, as always, anything that is destined to be 3D printing, if it needs to be customized or fit a certain application, that becomes a really good reason to do it. So
for sure.
Any other, like, when I think of metal 3D printing and the forward AM metal options, like, that's a real game changer, I think, in terms of what any, let's say we're working at a trade show and someone walks by, they don't think that metal is possible.
Yeah.
How would you tell someone, let's say you had like an elevator pitch of like, no, you can, and like, how would you guide that person who already knows about 3D printing but doesn't think metal is possible for them?
Yeah, so I would tell them, this is much more accessible than you might think. Because it is a metal powder with a polymer binder. Basically extruding it is just based on the polymer, and we print polymers all the time. And again, the post-processing is so well known that that's the technology we rely on. So there is that one extra, it is a big step, but one extra step of this post-processing. But it's well known, it can be done. We have experts that understand it. This is what I'm here for. Where people are like, hey, I want to print this in metal. Can you help me? I would be like, you can't print that, but we can make 2 tweaks and then you can, or something like that. So
accessibility really is, I think, the name of the game of people. Any like passive 3D printing user thinking that metal is not possible on their machine. This really opens that door, and that's the crazy part about it. And what you can design, how you can use things that are made out of real, legit metal. I suppose I asked the question, what's the difference in ease of 3D printing between 316L and 17.4pH? But how much harder is it to 3D print in metal than it is maybe PLA, ABS, nylon, those types of things?
The main thing I like to keep in mind with metal is it's not significantly harder to print. And I mean, one of the things that we do is by working with these machine manufacturers, we have print parameters that, our teams they're fully fledged. We have tested them just endlessly. So they are really ready to go on a lot of common printers in the industry. So that's, one hurdle is, we do have print parameters.
The print profiles are already taken care of.
Exactly.
For the most part.
Yeah, for a lot of different machines out there. And so that's kind of one hurdle. But really the biggest thing to keep in mind is if there's any defect in your metal part, a lot of people think, oh, it'll get fixed in debinding and sintering. No, it will not. Have a really nice looking green part, really print that well, and it will debind and sinter as expected. It will look great on the other end, but yeah, it will not fix your problems. So that's why I say focus on the green part, make that look good, and yeah, the debinding and sintering, won't be an issue then.
Defects and failures have a tendency to propagate
Yes.
rather than fix themselves.
Yes.
If you're going to 3D print something out of metal, like what's your workflow? And by that I mean, like, do you make your first part out of a different material and then try it in metal? When do you do the scaling? Like kind of all those like details.
Yeah.
Just talk me through your workflow of like your basic. I want this out of metal.
Yeah.
But how do I do it first?
Yeah, sure. So I'm definitely a jump right in type of person. So
Love it.
So it's straight to metal. But yeah, there are a few things to keep in mind. So when generating your G code, setting print parameters, things like that, one thing you do have to keep in mind is that during post-processing, the part will shrink. So we have to scale it up when we're designing. So in your print software. So you scale up like to 126% in the Z direction and 120% in X and Y. So that's a very important thing to remember. And then, yeah, really just checking your print parameters, making sure you have either a brim or a raft. That'll really help with bed adhesion. Very important to keep that bottom surface flat so that, again, when it goes through post-processing, it stays flat. There's no additional stresses. Again, gravity will win. Scaling up, and again, if we have a printer with set print parameters, I'm usually not changing much. I might change infill depending on
the specific part geometry.
Yes, exactly. Sometimes I want it fully dense, 100 or 105% infill. Other times, maybe I just want it printed quicker if it's a demo part, or you want a lightweight application, then I'll lower the infill. But other than that, I'm not changing too much. But yeah, then, get your file. We do have a metal Magic Glue adhesive, so use that on the build plate. Dynafix also works. So put that on your build plate so you get really good bed adhesion, and then print your file, print your part. One thing that we get asked a lot is, my part is now stuck to the build plate after it's done. And so what I say is we have a really easy fix to this, but just not everyone necessarily knows it. But soak the whole build plate in water and it will dissolve that adhesive, and patience is key here for sure. But eventually you should be able to like tap your part and it should come off the build plate, and then you don't risk anything happening to the part, anything happening to your glass build plate. So yeah, and then so then you have your green part, and then that's when you package that up. Very important step as well.
Yep, delicately.
Yes, bubble wrap that way more than you think you need to. They're more delicate than you think. But package that. If you shake the box, you should not hear anything moving around, laying around. Send that to DSH, our debinding and sintering partner. Wait a little bit, and they will send it back, and you will have a fully metal part.
Yep.
So that's kind
I would say, just to add two comments. One, the DSH debinding and sintering schedule is like posted, and you could like, it's very predictable, so it's not like wait an ambiguous amount of time. It's wait a very measured amount of time. And then when you're packing it up, pack it up like it's your baby and you're sending it off to college. The parts really are very robust. Like, you don't want them to break in transit, and rarely they do, but you just want to be as protective as you can. I'm surprised how robust the green parts actually are, though.
Yeah, it's really if you have like maybe a really small feature that needs to be more protected. But yeah, if you're printing something good like that, I'm not too worried.
Yeah.
But
yeah, I mean the robustness of the green parts consistently impress me.
Yeah.
And yes, I think the most failures I've had with printing in metal was actually getting thin parts off the build plate. when it's in the land of engineering guidance of fail early, fail often. That's failing very early in the process, all things considered. But certainly being delicate when removing it from the build plate. It would be one of my key guidances to anybody starting new with 3D printing with ultrafused materials.
For sure. Yeah.
3D printed metal stuff, what's the coolest thing you've held in your hand?
It's probably something that one of our machine partners, Ultimaker, one of their application engineers printed it. It was a hammer that was designed out of metal, and as well as a few of our other materials as well. So like the hammer head was metal, and then we had the base was one of our carbon fiber filled materials, and then the handle was a flexible, so it was soft and nice to hold. But yeah, it was sanded perfectly during it was a green part, and then post-processed, polished. It looks awesome. So yeah,
and actually functioned as a hammer.
Yeah, I mean, it is a fully functional hammer. I think it is the exact weight that a hammer is supposed to be. Like, everything was taken into account. So this is, it is an exact replicate of what you would expect.
Shout out to Dylan George. He's the hero designer of that thing. Yeah, that was rad.
Yeah, that one gets a lot of spotlight lately.
Nice.
But that kind of also highlights some of what also makes metal really unique and cool is that, so when it's a green part, I know it's robust, but it is still workable. So you can sand that part to get rid of layer lines. You can, glass bead blast it to make it look, even better, get rid of layer lines, and do any touch-ups, because anything that, what your part looks like is how it's going to look after debinding and sintering. So if there's anything you need to clean up or modify of it, you can. And then after post-processing, this is a fully metal part. It's not partially metal, like it is metal. And so you can post-process this like you would any other metal part. You can polish it, weld it, any machining you need to do. Yeah, anything like that you can do with this part. So there's a lot of flexibility and a lot of control over how you get to your end part, which I think is really cool.
Yeah, it is amazing. We've seen a lot of those case studies. We talked about them to one of our customers in the first metal episode, if you want to go back and listen to that. Like a lot of welding applications and like post-processing in really unique ways from some of those case studies, which are really cool. My favorite part about the Dylan George at Ultimaker who designed the hammer is it was his favorite hammer that he couldn't buy anymore, so he redesigned it and printed it himself. It was like no longer on the market.
I did not even know this part of the backstory.
Replicated his favorite 16-ounce hammer.
That's
and 3D
awesome.
Printed it because he couldn't find it in stores anymore.
That is so funny.
Another great use for 3D printing.
Yes, and really just shows that, we worked super closely with Dylan while he was doing this as well, and it's just an example of how we work through our distributors, through our machine manufacturers, but really at the end of the day, we all want to see 3D printing succeed. And so when we see things like this, we're all just thrilled and excited and want to share it with everyone.
Yeah, and that's, who's it for? Well, this stuff's for if you're printing metal replacement parts, or you're replacing hammers that don't exist anymore, or if you need customized fixtures and jigs that need to fit and cradle certain things, or end-of-arm effectors that need to be made out of metal, like those are, at the end of the day, the consumers that will be most benefiting from the accessibility of the ultrafused material to be able to print it on any old 3D printer anywhere.
Yeah.
And have the real complexity taken care of by DSH, and that's outsourced to the pros.
For sure. Exactly. That's what's really awesome about it is, any desktop printer you have can probably print metal.
That is amazing.
Yeah.
That is so amazing. So when it comes to metal, who's it for? And by that, I mean, what would printing out of 316L or 17.4 pH, replace, and why?
Yeah, so let's say you need a replacement part for your production line. The lead time on that might be really far out, weeks to months, and it might be super expensive, and you might need one part. Whereas with metal 3D printing, you can get that printed, send it in for post-processing. We have 2 post-processing runs a month. So within 2 weeks,
worst case 2 weeks.
Yeah, worst case, like maximum time. You could have your metal part back and ready to go. So that's a really big advantage, I think.
When it comes to, so that's like, I always think of the best use of 3D printing is the ability to, even if your end game is to print in metal, you could still iterate in PLA like many times on your desktop until you see it successfully and have that vision of, I'm ready to proceed here. But the 2 advantages, like iteration and then timeline, and I always think like, when an engineer is under the gun, I think of like some engineer at Tesla who's just like, finances aside, they're just under the gun to like increase or like reduce the timeline for anything. I think although it is a worst case 2 weeks, best case 3 days kind of for the debinding and sintering process, that still allows you to save a lot of time compared to waiting for the machine shop to, create the CNC code, build the fixtures. I mean, when it comes to complicated picture, like use a 5-axis or flip this thing over, like the time saving still can be there. Unless you're machining it yourself, then you can knock it out pretty quickly, but still not as quickly as the 3D printing side of things. And then the last one is like the financial savings. Like what's the cost of the metal? Is it cheaper or more expensive than maybe CNCing it out of billet? Do you know?
Yeah, I would. I don't know exact numbers, I will say, but in general, it should be much cheaper. So, I mean, you can buy a spool of filament. That's your material. That's what you're working with. You don't have any waste material there really either. So that's a huge cost savings.
The waste is like this incredible part of like, oh, we're not making a bunch of chips that are going to get recycled, hopefully.
Right.
But instead, you're only laying down the plastic metal in places where it needs to be.
Exactly. So the material you're laying down is what you're going to use. And yeah, debinding and sintering also affordable. It's, for us it's $50 per kg of material in general. It's a fixed cost. You know what you're getting into, and it's not crazy expensive either.
Yeah. So the same sentiments of timeline, iteration, and financial savings seem to apply to the metal materials just as much as the plastic materials.
Yes, absolutely.
Cool. Any last words of guidance or things to mention that you might be working on that are new or coming down the pipeline or anything?
Yeah, so really for us, I think some of our newer materials, which we did mention a little bit, but our flexible materials are very exciting as well. Again, you can really utilize design to optimize your end part and really get the full potential of our flexible materials. We have a TPU 85A, 95A, and 64D, which those number letter combos represent the different hardnesses. And for all of those, we, again, pulled off of, they're based on BASF raw materials, so the elastine chemistry. And that's really where I think our materials are going to set themselves apart. We can, utilize the experts, whether it's, BASF, DSH, whoever it is, to really make our products and the entire process as good as they possibly can be. So.
Well, robust, repeatable, and then if you're standing on the shoulders of like metal injection molding technology that's been around for 30 years, or BASF chemists that have technical data sheets for the raw materials for decades, I think that's really where in this land of newcomers to 3D printer technology, like BASF stands out by having that substance and that reliability as a brand over time.
Yeah, thanks. Yeah, we have a ton of information about our products, so really it's being able to share that, get it out there, and have people come talk to me about it. That's what I do. Is any customer question, happy to help with that.
Awesome. Is there a way for people, what's the best way, not for people to contact you, Emma, directly specifically, but to find more information about BASF and the Forward AM products?
Yeah, so generally that would be on our website, so forward-am.com. There you can find all our technical data sheets, one-pagers, applications, use cases, and if you need more info, you can contact and reach out through that way. A lot of times it'll end up with me, but as well, I can end up with our sales team, other application engineers, but that's
cool.
really
your
where
group.
support.
Nice. And most of the materials are available at MatterHackers.com as well. Certainly all of the filaments materials, many of the resins, some of the powders are all available at MatterHackers. And I'll just take a moment to thank you guys and BASF for the partnership over the years. The industry as a whole is benefiting from BASF Forward AM just participating in this market and helping to lead the forefront of technology, materials development, which is, I've said it many times, I think where 3D printing will grow in the next 10 years will be more based on the materials and less based on the hardware that at the end of the day, if anybody notices, it got in their way more than anything. But yeah, thanks for hanging out with us today and infiltrating and letting some of that, like you said, you guys have more technology and resources than are like perceivedly available, but I think this is a great way to say, yeah, it's all accessible. Come get it. So.
Absolutely. Yeah, no, thank you for having me and having us here. And yeah, it's always great working with you guys and supporting you. You support us just as much. So it's a fantastic relationship. So thank you.
Cool. Right on. Thanks for your time, Emma.
Yeah, absolutely.
Thank you for tuning in. If you want to learn more about BASF's product portfolio, where to get them, or really everything about 3D printing, go to MatterHackers.com. See you on the next one.